Algebra 2, Chapter 1.2, Characteristics of Function Graphs, homework. This is exercises 12 through 16. And in this set, I'm going to do problems 13 and 15 and leave it to the viewer to do the remaining three problems, 12, 14, and 16. Although I may talk about a couple of these, maybe 16. 13, the following describes the incidence of mumps in the United States from 1984 to 2004. From 1984 to 1985, there was no change in the incidence of mumps. So what you're looking at is this paragraph, and you're just your words and numbers. What you're trying to do is use mathematics to translate the text to a graph, which creates a picture, a visual of what is going on and the trends and mumps and so forth. So what I recommend doing is taking creating a table, and then we're gonna go to the numeric value from the text and then transfer to the graph on the right here. And our coordinate plane is set in terms of x-axis and a y-axis, and the years are represented by these values 0 through 20 along that x-axis. And we are going from 1984, and it looks like every year represents a mark here. So we're starting in 84, so I'm going to put 84 down here just to remind us of where we are. And then I guess every 2 years, so this would be 86, 88, okay, 92, another 4 years, 96. This will be in year 16 will be 2000, and then here this 20 will be 2004. Is that right? Yeah, 2004, which should be 20 years after 84. Okay, let's go ahead and look at this. From 1984 to 1985, there was no change in the incidence of mumps, staying at about 1 case per 100,000 people. So at year 0, which represents 1984, we had 1 case per 100,000 people. Then in 1985, which is year 1, there was no change, so we call that 1. Then there was a spike in incidence of mumps, which reached a peak of about 5.5 cases per 100,000 in 1987. Where's 1987 located? Yeah, that's going to be the 3, right? That's 88, that's 87. So year 3 is going to be 5.5. Now what happens between year 1 and year 3? Doesn't say. That would be 1986. We don't know. So that's a gap in our data. Over the next year, there was a sharp decline of incidence in mumps to about 2 cases per 100,000 people in 1988. So that's going to be year 4 is 88. So I'll put 4. That's 1988. And that's going to be 2 cases per 100,000 people. Okay, then from 1988 to 89, there was a small increase to about 2.5 cases. So that's going to get us to year 5 here, and that's going to be 2.5 cases. And then this is followed by a gradual decline, which reached a minimum of about 0.1 case per 100,000 in 1999. So where is that? Well, 2000 is 16, so 15 is going to have to be 1999, so 15, and we have about 0.1 cases per 100,000. And for the next 5 years, so if we take 15 and add 5, we get to year 20, which translates to 2004. So we say no change, so that's going to be also 0.1. So given the data, that's as well as we can do. So let's go ahead and plot our points. We have the point 0, 1 here. That's our first point. And then we have no change after the first year. And then the next data point we have is third year. We have 5.5. So that's going to be 1. And you know something? I've actually made a slight mistake here. These years go by 2, so that's second point's going to have to be right here. Okay, next one. 3 is 5.5, so 3 is 5.5, so about here. Yes, very sharp increase. Next data point, 4, and the next year we went down quite steeply. So here in 1988, we went down to 2 cases. It looks like we had an outbreak, and then we had some radical inoculation type of vaccines that are taken down. Okay, and then for the next 10 years, let's say the next 10 years, yeah, by a gradual decline, 89 to 99, we went down to 0.1. Okay, so here's 99.1, which is just right here. And then we have no change for the next 5 years. So we're about right here. Now we can kind of line up the dots. Here's this one here. And then we're going like this. Oops, wrong one. We're going straight up here to that 5.5. And that's not, I mean, you can, it's probably not a straight line, but given that's the data we have, try to get as close as possible. Then we had that steep decline that following year, so we put that like this. What I'm going to do, I'm going to go to the tools here and just get the line and have that line just put on there like this. It's kind of a thick line, but that'll work. Now I'm going to have, I'll put this line up here. There we go. And then we had the gradual decline, and it could kind of curve decline, or it could be a steep decline. I'm going to just go ahead and make it a straight decline to the year 1999, and finally going flat for the last 5 years. And there we have it. So that's basically what it looks like. Let's go ahead to problem number 15. I hope that was helpful. Again, number 14 looks like a similar process. 15, golf. The table shows the height in feet of a golf ball at various times in seconds after a golfer hits the ball into the air. And this time we are given the table. We don't have to construct the table ourselves, as we did problem number 13. So let's go ahead and plot the data, graph the data in the table, and then draw a smooth curve through the data points. Okay, here it says quadratic function, so you'll probably see a downward opening parabola, I would guess. So first point, at time 0, we have height 0. Then at 0.5 seconds, which is going to be right here, 0.5 seconds, we are at 28 feet in height, so about right here. Then we have at 1 second, we have 48 feet in height, so here's 1, 48, just a little bit less than 50. Then 1.5, we have 60 feet, so here's 1.5. 60 feet will go right up here. Next, we have, at 2 seconds, we have 64 feet. So 2 seconds, go up here, 64 feet. At 2.5 seconds, we're at 60 feet. So we've reached our maximum now in our going down. At 3 seconds, we are at 48 feet. And as we I'll make that statement later. I'm going to make a concluding statement. Let's finish a couple more points. At 3.5 seconds, we're 28 feet. And at 4 seconds, we are at 0 feet. And so we can look across and see that we have horizontal symmetry about x equals 2. So I've just drawn in the half seconds, not 100% necessary. So the curve is going to go like this. What I think just wants to go to the left a little bit. See if I can, that's going to the right. Okay, that's better. Here we are rounding at the top, coming down. Okay. All right, there we are. There we are. Now, so that's part A. What is the maximum height that the ball reaches? Well, it looks like at 2 seconds, we are at 64 feet. So answer to part B is 64 feet. On what interval is the golf ball's height increasing? Well, we are increasing from t, so in inequality notation, we are increasing from the moment the ball is hit, time equals 0, up into 2 seconds. Okay? And if we want to write this in interval notation, we can write this as bracket 0, 2. Okay? On what interval is the golf ball's height decreasing? Well, it's going to be afterwards, so between 2 and 4 seconds. So between 2 and 4 seconds. And again, in interval notation, open with a bracket, 2 to 4. And it can be argued that parentheses may be used instead of brackets. But that's it. Number 16 is a matter of, you're given an equation. It should be very easy. So really that's all for now. Good luck, and thanks for viewing.